America didn't just build trains. We built machines so powerful they outran their own future. This is the story of an 80-year arms race between fear and velocity. Every time people declared this the absolute limit, we broke it. And the final machine we built, the big boy, was so undeniably American that it made itself obsolete. Union Pacific's big boy, 1.2 million pounds of steel, 133 feet long, with enough tractive effort to pull 16 Statues of Liberty up a mountain. But here's what the plaques do not tell you. This locomotive only existed because every previous solution had painted America into a corner we could not get out of, except by building something absurd. Today, I'm going to show you how crisis, not convenience, drove every breakthrough, how the Civil War forced us to build a national network, how the Great Depression made us obsessed with speed, and how World War II demanded a machine so powerful it broke the scale of progress itself. And here's the twist. The big boy was so good at its job that it proved steam had nowhere left to go. The perfection of the machine is what killed the era. First step. The first step is by far the most important, and yet also the most forgotten. August 28, 1830. Peter Cooper's Tom Thumb, the first American-built steam locomotive, is about to race a horse-drawn carriage on the Baltimore and Ohio Railroad. The stakes are high. If steam loses, investors will pull out, and the entire concept of rail travel dies in America. The Tom Thumb takes an early lead, belching clouds of vapor as it accelerates. The gray horse and its stagecoach fall behind. Cooper's passengers cheer as the iron horse proves its worth. This is the moment. Steam is about to win America's future. And then the drive belt snaps. The boiler loses pressure. The locomotive wheezes to a crawl. The horse surges past, reclaiming its lead with effortless grace. By the time Cooper frantically repairs the belt with burned hands, it is too late. The horse wins. Steam loses. But here is the American part of the story. Cooper lost the race but won the argument. The Baltimore and Ohio Railroad directors came away from that test run so excited about the locomotive's speed, power, and ability to navigate curves that they ordered steam locomotives anyway. Because Americans do not need to win to be convinced. We just need to see that it is possible. They had just proven steam could work. Now they had to prove it would not kill you. The Tom Thumb was barely a locomotive by later standards. A 220 wheel arrangement, a vertical boiler made from rifle barrels and weighing less than 1 ton. But it reached from 15 to 18 miles per hour and could pull a passenger car up grades, unheard of for something that small. Cooper's innovation wasn't in refinement, it was in proving the concept could be scaled up. And scale up we did. Between 1830 and 1860, boiler explosions destroyed over 500 locomotives and killed more than 500 people. The problem wasn't speed, it was pressure. Engineers were pushing boilers to between 100 and 120 pounds per square inch, with no safety standards, no pressure gauges reliable enough to trust, no understanding of metal fatigue. It was like driving a car with no brake pedal and praying the road stayed flat. The solution didn't come from engineers, it came from the one force that always drives American innovation: existential terror. Because just when they thought they had the explosion problem managed, the Civil War arrived, and the Union's survival depended on moving 3 million soldiers and 1 million tons of supplies across a rail network that wasn't actually a network. Here's what they don't teach in school. In 1861, you couldn't take a train from Boston to Washington without changing cars 5 times, not because of enemy sabotage, but because the tracks were different widths. 5 times. The Union had 30,000 miles of track, but it wasn't a system. It was a collection of fiefdoms, each with its own gauge, its own timetables, its own ego. Moving a single cannon from Pittsburgh to Virginia took 3 weeks because crews had to unload it from one train, carry it to a different platform, and reloaded onto a train with narrower or wider wheels. The Confederacy had the same problem, but worse. They had less track and fewer engineers to maintain it. So Lincoln did what American presidents do when the nation is at stake. He nationalized progress. The Pacific Railroad Act of 1862 didn't just fund the Transcontinental Railroad, it mandated standard gauge, 4 feet 8.5 inches, an arbitrary measurement inherited from British mining carts and Roman chariot axles, now enshrined as the backbone of American power. You know the Golden Spike story, 2 locomotives meeting nose to nose at Promontory Summit, Utah in 1869, linking east and west for the first time. But here's what matters. When that connection was made, it didn't just connect geography, it connected time. The journey from New York to San Francisco dropped from 6 months to 6 days. For the first time, a citizen in California could read a newspaper from Washington, D.C. that was only a week old. A rancher in Nebraska could sell beef to a factory in Chicago and know it would arrive fresh. A nation became a single, pulsing organism, unified by steel rails and steam pressure. This is where the American obsession with velocity becomes a national identity. Because just when they solved the gauge crisis, a new competitor appeared. And it was about to start an arms race that nearly destroyed the railroads. The year is 1929. The stock market crashes. The Great Depression begins, and the automobile is eating local traffic while the airplane is making trains look ancient. The railroads face an existential question: adapt or die. They make a desperate decision. If they can't beat the competition on convenience, they'll beat them on pure, unadulterated speed. Enter the Streamliners. Not just trains, but statements. The Burlington Zephyr, the Milwaukee Hiawatha, the Pennsylvania Railroad's S1, they didn't just move people, they moved the national imagination. Gleaming stainless steel bodies, Art Deco interiors, diesel-electric or high-pressure steam propulsion, and speeds that made conventional trains look like they were standing still. May 26, 1934. The Pioneer Zephyr leaves Denver for Chicago non-stop, 1,000 miles in 13 hours. It hits 112 miles per hour, so fast that reporters on board, fence posts blurred into a continuous line, telephone poles became streaks, and the horizon bent around them. You almost forget you are moving, until you look out the window and realize the world is warping past you at a speed that should not be possible on flanged steel wheels. The Streamliners were not just fast, they were aerodynamically sophisticated. The Zephyr's shovel-nose design reduced air resistance by 40% compared to conventional locomotives. Milwaukee's Hiawatha F7 could sustain 100 miles per hour for hours, hauling full passenger consists. These were not experiments, they were production machines that rewrote the physics of rail travel. But speed came at a cost. They were optimized for level track and light loads. Put them on a mountain grade with heavy freight and they were useless. By 1937, America had the 10 fastest trains in the world. We had cracked 100 miles per hour on flanged steel wheels, something European engineers said was physically impossible. The Milwaukee Road's Hiawatha covered the 78 miles between Chicago and Milwaukee in 75 minutes, averaging over 60 miles per hour with multiple stops. The Pennsylvania Railroad's S1, a 6446 duplex behemoth, was rumored to have hit 133 miles per hour on a test run, though the railroad never officially confirmed it. But here's the secret. Every time we pushed faster, the physics got more dangerous. At 100 miles per hour, a rail joint irregularity that would barely register at 40 miles per hour becomes a violent hammer blow. Track maintenance intervals shrank. Wheel wear accelerated. The faster we went, the more fragile the entire system became. It's like buying a sports car that eats through tires every month. Sure, it's expensive and impractical, but when you absolutely need to get from Chicago to Denver in 14 hours instead of 20, what else are you going to do? Take a stagecoach? The Streamliners were magnificent. They were fast. They were profitable on the right routes. But then December 7th, 1941 changed everything. Pearl Harbor. And suddenly the Rocky Mountains said, Speed is cute. Let's see you do it with 10,000 tons of war material at a 2.2% grade. The United States enters World War II, and suddenly the streamliners are useless. The military does not need passenger trains traveling at 100 miles per hour. It needs brute, unstoppable force to haul tanks, artillery, ammunition, and supplies over the most punishing terrain in North America. The railroads carried everything. By 1944, they were moving more than 90% of domestic military freight and 97% of military personnel to bases and ports of embarkation. Troop trains ran 2,500 times per month. Freight tonnage nearly doubled from 378 billion ton-miles in 1940 to 746 billion ton-miles in 1944. And the hardest job of all fell to the Union Pacific, moving war material over the Wasatch Range between Ogden, Utah, and Green River, Wyoming, a 1.14% eastbound grade that conventional locomotives could not handle with profitable tonnages. Enter the Union Pacific Big Boy. Not a locomotive, a statement of industrial might. Put 2 Boeing 737s on train wheels, that's your big boy. How powerful? Enough pulling force to drag 16 Statues of Liberty up the Rockies. The specs almost feel like we're making them up. 1.2 million pounds total weight, 133 feet long, 6,290 horsepower at 41 miles per hour from a boiler running at 300 pounds per square inch, and 135,000 pounds of starting tractive effort, more than any locomotive ever built. The Big Boy's wheel arrangement, 4884, tells you everything about its design philosophy. 4 leading wheels to guide it into curves, 8 drivers on the front engine, 8 drivers on the rear engine, 4 trailing wheels to support the massive firebox. The key innovation was articulation. Unlike the Pennsylvania Railroad's rigid T1 duplex, which spun its wheels fighting itself, the Big Boy's front engine could pivot independently. 2 sets of cylinders, 2 sets of drivers, but working together, not against each other. On curves, it flexed like a snake. On grades, it pushed like a battering ram. It was the solution to every problem the duplex created. This wasn't a train. This was America's mechanical middle finger to gravity itself. Between 1941 and 1944, the American Locomotive Company, Alco, in Schenectady, New York, built 25 of these monsters at a cost of $265,174 each, about $5.7 million in today's money. They were designed for one job: haul 3,600-ton freight trains up the Wasatch Grade without helper locomotives. In practice, they routinely pulled 4,200 tons, and during a test run in 1943, Big Boy 4014 pulled 65 freight cars, generating a maximum of 5,530 horsepower. During the war, they moved everything: M4 Sherman tanks, artillery shells, crated aircraft, food, fuel, replacement parts. 90% of domestic military freight moved by rail, and the Big Boys were the backbone of Union Pacific's war effort. A single Big Boy could replace 3 conventional locomotives. It could pull 100 cars up a grade that would stall early diesels. It was in every sense the perfection of steam technology. But perfection comes with quirks. The Big Boy was so powerful it came with a warning: never open the throttle past 50% on level track. Why? Because at full power, the driving wheels would generate enough force to actually distort the rails, heating them to the point where they would lose their temper and crack. Union Pacific engineers learned this the hard way in the early 1940s when rookies, testing the limits, would occasionally heat-damage sections of track. The unofficial rule became, if you melt the rails, you get retrained, not fired, because you do not discharge a guy for proving your locomotive is too powerful. Imagine that performance review. Employee showed excellent initiative and strong understanding of throttle mechanics, but liquefied $50,000 worth of infrastructure. Recommend additional training and a course in restraint. Big Boy 4014, restored by Union Pacific in 2019, still exists today. It is the only operational Big Boy out of 8 survivors, and when it runs on heritage tours it pulls 12 to 15 passenger cars, a far cry from its wartime duty of 100-car freight consists, but still enough to prove it could pull that load if Union Pacific allowed it. It is the world's largest operating steam locomotive, a living tribute to an era when bigger truly was better, but building the perfect steam locomotive had a cruel twist ending no one saw coming. By 1955, just 11 years after the last Big Boy rolled out of Alco's factory, steam was dead, not because it failed, but because it succeeded too well. Here's the irony. The Big Boy was so specialized, so perfectly adapted to one brutal job, that it proved steam had nowhere. You could not make it more powerful, the rails could not handle more force, you could not make it faster. Articulated locomotives were not designed for high-speed running, and at speed they would develop a violent lateral oscillation called nosing that destroyed track. You could not make it more efficient. The laws of thermodynamics had been pushed to their absolute limit. Steam locomotives, even the best ones, converted only 6 to 8% of coal's energy into useful work. The rest went up the stack as heat and smoke. Meanwhile, diesel-electric locomotives had arrived with 3 things steam could never match: standardization, modularity, and most importantly, lower labor costs. It was not just about efficiency. A steam freight train needed a 5-man crew: engineer, fireman, conductor, and 2 brakemen. A diesel needed 2, engineer and conductor, because diesel units did not need constant firing and water stops. Diesels could run 500 miles without servicing. A Big Boy needed water every 100 miles and coal every 150 miles. Diesels could be connected in multiple unit configurations. 4 units of 1,500 horsepower could be controlled by 1 engineer, giving 6,000 horsepower with operational flexibility steam could not match. And when 1 diesel unit broke down, you could simply uncouple it and continue with the others. When a Big Boy broke down, the entire train stopped. After World War II, labor costs were rising. Unions were striking for better pay and conditions. The railroads were hemorrhaging money to trucks and airplanes, which were stealing both freight and passengers. The financial equation had shifted. The savings from running diesels, with fewer crew, less maintenance, and higher availability, outweighed steam's raw power. The Big Boy's success was its epitaph. It showed that steam had peaked. You could not evolve beyond perfection. So the railroads did the most American thing possible. They pivoted. They replaced their magnificent, perfect machines with smaller, modular, interchangeable units that could be run by 2 guys and serviced anywhere with basic tools. The diesel did not win because it was better at any one thing. It won because steam had become too good at being itself. The Big Boy was the final chapter of a book that had to end because we had written ourselves into a corner where only something absurd could work. Once you build the absurd, there is nowhere left to go. The Big Boy still runs today because we need it to, not for freight. Union Pacific could haul more tonnage with a trio of modern AC400CW diesels and do it cheaper, faster, and with less drama. No, the Big Boy runs for memory. For the same reason, model railroaders spend years building perfect 1:87 scale versions in their basements. Because in those curves of cast iron and those massive driving wheels, we see something more than engineering. We see a nation that bet everything on steel and steam. That turned crisis into velocity, fear into innovation, war into industrial triumph. That built machines so powerful, they broke the very concept of progress. The evolution of American trains isn't a story about technology. It's a story about what happens when you tell a nation of tinkerers and fighters that something is impossible. They build something bigger, And then, when bigger stops working, they build something smarter. The big boy taught us that perfection is the end of evolution. Once you have built the ultimate expression of an idea, you cannot improve it. You can only replace it. Steam did not lose to diesel because it was weak. It lost because it had won two completely, leaving no room for the next step. In the end, the big boy taught us an important lesson. Just because you can build something does not mean you should, unless it looks really cool and sounds like thunder rolling across the plains. Then absolutely you should. We'll figure out the economics later. Here's my question for you. Was the big boy's obsolescence inevitable, or did we kill it because we got scared of our own power? If we'd kept pushing steam instead of pivoting to diesel, what would we have built next? Tell me in the comments, and if you think I'm wrong about any of this, even better.